Hi, today we're going to look at our last group of reactions for organic chemistry, and that is hydrolysis reactions. In a hydrolysis reaction, we are adding water, which we look at as HOH, to break a bond in a biomolecule is where we'll see it most often. This is an early step in digestion, and we're going to see that it always requires enzymes. As a shortcut on my whiteboard today, I'm going to use E for enzyme, but otherwise you should always write out enzyme over the arrow. So the first hydrolysis reaction we're going to look at is shown here below. That's Ester Hydrolysis, which we find in the biomolecules triglycerides. And so in any hydrolysis reaction, we're going to find the two heteroatoms, and we're going to say, here's my reactive functional group, identify it as an ester, and then think about breaking it right down the middle between the heteroatoms. Now, onto each side of that, I'm going to add a piece of my water. The OH, we're going to see, always follows the carbonyl, so that will add to that side, and the H goes on the other side. So when I get to my products, I want to copy carefully what I see in the reactant. So here was a line going down to an oxygen, and then add the H onto that. And then for the other side of it, I had up and then down with the carbonyl, and then I added an OH. And be careful to keep this oxygen between the hydrogen and the carbon up here. So the products of an ester hydrolysis are an alcohol and a carboxylic acid. Next we'll look at a peptide hydrolysis. So now we're looking at hydrolysis in proteins, and the bond that's going to be broken is known as a peptide bond or an amide bond. So first part of the problem, we want to identify the reactive functional group, which in this case is an amide, and we are going to break it right between the heteroatoms again. Water will add on. The OH is going to add to the carbonyl side. The H is going to add to the amine side. And then I see I have my, again, acid and enzyme. Peptidases would catalyze these types of reactions. Now I'm ready to copy my products. So up, down, NH, and I now have another proton on there. I could also write it as NH2. The second product, up, down, carbonyl, and I added an OH onto that. So the products of an amide hydrolysis are an amine and a carboxylic acid. Last of all, we'll look at hydrolysis in carbohydrates. So we're looking at hydrolysis in carbohydrates now, and that will be breaking the glycosidic or acetal bond. For simplicity's sake, I'm leaving off all of the other OHs here, but you should always include them and copy them carefully. We're going to focus in on where the chemistry happens though. First, identify the reactive bond, and that's going to be the glycosidic bond right here in the middle. Okay. Next, we know that we're going to split this right down the middle, and each sugar is going to end up at the end of this reaction with an OH. So we currently have one oxygen, and then we're going to have an additional oxygen and two hydrogens from the water. So when you get to your products, you want to copy it carefully. Same rings, whichever directions each of the OHs are, do that carefully. I can maintain the direction that the glycosidic bond was pointed, so pointing down here, which is an alpha anomeric carbon because it's right between the two oxygens there. And then the other product, keep the same hexagon, any OHs that were present, and again I want to fill in an OH. So in a carbohydrate hydrolysis, here I see that I started with a disaccharide and I ended up with two monosaccharides. So that wraps up hydrolysis. We're always breaking a connecting bond by adding water to it in the presence of enzymes and often acid. If a molecule is modified or just naturally does not have an enzyme present that can digest it, keep in mind that these initial bonds breaking are essential to the beginning of digestion. If you cannot digest a molecule, then you will not get calories from it, and it will just pass directly through your digestive system, like some sugar substitutes, like fiber, like sugar alcohols, molecules like that. All right, have a great day.